I will teach you some of those patterns and some of those communication things from very inspirational sci-fi TV show, right? It's the Star Trek, and we're going to be talking about all the things. I will try to explain all the things through the lens of Star Trek. Jean-Luc Picard will be representing our service. We're writing some of the application where we need to bring this application to production. So think about this application boldly go in where no one man have been before. So in this case, our microservice going into production. And we do have a couple things apart from solving the business task, apart from solving the problem that the business wanted us to solve. This can be like order service, it's going to be billing service, it's going to be shipping service, something that we need to solve. Like as a developers, we need to implement this. And apart from that, many developers constantly forgetting about the day two responsibility. It's good that we're trying to educate many people these days in terms of ways of DevOps and how developers need to communicate with operations people in terms of understand the responsibilities, what kind of stuff needs to be implemented in this application. And we start talking about things, authorization, notification, some of the things to prevent denial of service attacks, some of the things to prevent work against the legacy APIs. Some of the APIs that you implemented your system will be obsolete soon. You need to update things and how you will support all these clients in the future. You need to think about this, how you can do proper monitoring, end-to-end tracing, some of the logging functionality, maybe even caching of some of the data where you need to do this, and how you can do this. So and here I will try to bring this metaphor and see how far I can go with this metaphor. Now, there's a neat part. You don't have to. If you don't know how to do this, you really don't have to, because there is a set of program components that allow you to implement this without any problem. So essentially, how I see the gateway, API gateway, as a system that provides you with some additional augmentation. If you remember in the Star Trek, the Borg collective, they were pursuing perfection in terms of how these species will communicate. So in this case, if you will have some of the things that, or you don't have some of the things, those things will be provided to you at no cost. If you want to have a fancy augmentation for your as a faceplate, you will get this. If you want to have this like a fancy augmentation for your arm, you will get this for free. For the Borg collective will provide this to you. So I think that you can think about this when you become a drone in the Borg collective, you getting all these superpowers of the gateway for free. So essentially, with your microservices, with the additional augmentation, becoming a very super powerful microservices, right? So you will be with the Con gateway, you can enable all this functionality on the side of the gateway. So your external clients will talk to gateway. They will be talking to. Let me show you where are we standing with this. So your customers, your API calls would be engaging with your gateway, and the gateway will translate specific call to your service that will talk in gRPC, REST, maybe even some database calls. We will talk a little bit about some of the event-driven patterns with the thing called Kafka. You probably heard about this, and we're going to talk about this more today. So this is where your gateway brings more superpowers to your system, and you never need to implement those. There's hundreds of plugins available that can implement authentication, authorization, integration, third parties, etc. So that's it. Next thing is that we're going to talk what your services will be doing in the future. So I started this conversation with small module. We're starting this with the small module that we will be augmenting with some of the functionality that provided by gateway. But you have multiple services. You need to communicate through the services. And the next thing is that we're going to provide a custom or common way how the microservices will be communicating. This talk is all about microservices communicating and the ways how they communicate. You can actually put the gateway on top of your microservice and go talk to other microservices that has a gateway in front of this. It's, you know, some of the things that we were doing years, maybe not so often right now, but you might be heard about some of the things when you go into production. Some people, operation people saying, oh, we need to put load balancer in front. That's essentially load balancer in the very crippled version of that things that API gateway can do, apart from the doing load balancing. Now we talk into how we have like thousands of services now, and we start thinking about the things not from perspective of pets, but from perspective of cattle. So we want to deploy microservices every day. We don't want to them to be like a super difficult to communicate. We don't need to know their address. We just know how we can discover those. And this is how we go into mesh. And from perspective of Borg, that's called assimilation. You become a Borg collective and you will be connected to the hive mind. So this is how your services start communicating. Once you become a part of the Borg collective, your services will join the big Borg collective, and there would be easy to communicate between those. You always have a connection. You will get a unified set of tools, how you would communicate, and you will communicate through this with other components. And this, our microservices will communicate to each other through this, the bigger mesh that allow them to communicate. And this is how it would look like. Your application will, all these components will just will be plug and play. Some of these meshes actually can be communicated together. And this is what the Kuma can do. Kuma is open source, the service mesh implementation that supports deployments across multiple different platforms, including heterogeneous platforms. So you can deploy your one mesh in one data center, another mesh in another data center, third mesh in another, even maybe, I don't know, you have the virtual machines. And the only thing that mesh will have kind of slightly the way how the mesh will be getting its signals or getting this configuration is through a thing called control plane. So each Borg collective member will behave as a data plane. So data plane will receive some of the comments from control plane. So in this case, it's going to be a Borg queen, send all these requests to this. And if there's communication would be lost between the queen and between the particular drone. For those of you who are not the sci-fi geek, drone is the individual member of the Borg collective. So with this, your drone still continue to operating, and it will be working based on the some of the commands that were sent before the network was destroyed. So this is how it looks like from perspective of, let's get back, let's bring it to the normal diagrams, right? So we're bringing this into world of the architectures that were the diagrams, architectural of the draw diagrams. So the control plane, this is the brain of operation, and the control plane can operate over multiple zones or multiple Borg cubes. We have a cube 1 and we have a cube 2. Communication has happened in the real world by a small thing called proxy. So remember when we were talking about the gateway proxy, you can use some of those terms as, sometimes people using this as a synonyms. In this particular case, this small instance of this proxy provides a similar set of functionalities that I outlined previously when I was talking about gateway. And through this communication is actually happening. So your service as a new member of collective, you don't need to know anything about the Borg collective before. So everything would be provided. As I said, you will get the fancy augmentations. In this case, you will enable observability in your service. You will enable authentication, authorization, zero trust security, some advanced policies in order to doing some communication. You can have a sub-meshes. You can establish communication between individual like cohorts. You can create the small armies, like small squads of your drones, and this is everything can happen through control plane. So as a as a Borg queen, we can control this one. So that's how it looks like from perspective of this application. And this is where we go into space and go into different quadrants. With the single mesh, we can create one big mesh that is going to be GCP, it's going to be AWS, it's going to be Azure, and your application will communicate to each other. The drones from one cube can communicate to drone to another cube without directly communicating to this. They will be communicating through proxy, through this medium that your Borg collective provides. All right. And this is how it looks like from perspective of the real world, where you can have deployments in the different places, and you will see this in the UI. Now we learn a little bit about a gateway and proxy. We talk about mesh and how the things are communicating. Hopefully you will learning something from this. Do not forget to throw some of the questions right now, because we will have some time to talk about some of those patterns. Now, all right, so Victor, but like it's all cool and nice. Everything is great. However, like where's the Kafka comes into play? It turns out, and I spent significant time in my life talking about this. It turns out that sometimes this unified approach to communicating services, or like a too simplified, because your services rarely operate or communicate to each other without having the context, without having some of the knowledge about what kind of data is going there. And it turns out that many people use Kafka as a bus to communicate those services. And those services can communicate in I can say in the data aware mode, right? Because they're communicating through the certain pattern that we'll talk in a few minutes. Obviously, when I'm talking about data, I cannot miss this opportunity to provide this fun pun to data aware mesh. So data was also assimilated at some point during the First Contact movie. So that's you have it. Like some people who are expecting to have a data reference in the Borg talk, you have it now. Okay, so my friend and my former colleague Ben Shapira, if you folks doing anything with Kafka and you're not following Ben Shapira, you're doing things wrong. Ben Shapira, awesome speaker, awesome author of this definitive guide, Kafka for definitive guide. Second version is coming soon. So she did the talk where she also talking about how service mesh would be comparing to Kafka. And one of the things when they started talking, many people started using microservices as and they communicated through API. And very soon they find out there's different microservices to tangle to each other. And one of the approaches is to untangle this communication by providing this unified bus. Specifically, like let me show you the example of this log. And one of the things what we can see here in this log, we see there's some of the events happening, and based on those events, based on those things that we have in our log, we can restore history of the system. So in this particular case, each event will have a time. So we know when it happened, this event. And this event will be stored somewhere. Usually it's event store. And also will be, all these events will be ordered by time. And the things happen here. So there's client doing something, stream client doing something, consumer doing something. And this is how the time is growing. It's a time, right? Time. So the same concept of log that you're using in your application development was taken as a data structure and implemented as a distributed log inside the Kafka. Kafka is event store that captures all event happened in the system. So one service will create some event and post this into Kafka. So other systems who will be interested in this event will be responsible to consume it. And the way how it looks like, yeah, some people are saying, Victor, are you talking about like the log4j? No, we're talking about log as a data structure. And this is how you can entangle by providing kind of like a indirect communication with your consumers of your service. So for example, service one publishes into topic one, and there would be multiple consumers who will be interested in this. So instead of this service going here and getting data from service one, they are not. they are communicating through the topic. And the good thing, they become decoupled and they don't need to know about the existence of each other through this topic. So in this case, this is a totally disconnected communication. Same thing here, like service 2 publish here, and the service 3 and 4, service 3, 4, let's call it 5. And service 5 will consume this data from other sources. It can be consuming data from other services. For example, this 5 also consuming services from 3 and 4. So in this case, you might argue in terms of like, yeah, we don't really fix the detangling, but I think that's also allows persistent messaging of your messages, and also to bring this idea back, Kafka. Think about Kafka as kind of a delayed queue for your emails, and again, a reference to Charlie from It's Always Sunny in Philadelphia. You have this delayed communication between the services. Services can be down while one of the things will go up. So let's bring it back to our things. This is basically 3 most important slides of this talk. Hopefully you get a little bit understanding from perspective like how one thing will be connected to another thing. So let's talk about 3 patterns, like what you will take from this talk. So first pattern, like if you're doing everything with Kafka, forget about this gateway, forget about meshes. This is something that if you Kafka guy, this is you will do like all day long. You will be using this pattern called service event coordination. So essentially you have a message bus that will storing these events, and different services will be providing data to the different topics. This is what you saw on the previous slides, and that's it. They will be disconnected. They will do anything together. So everything would be nice and fine. And these services can be down. These can be up in a different time, because this service, this event store will store this data forever for them. And this is how you will be doing this, the microservice communication, if you don't have anything else. But we're coming into the world of where you need to have a like overall control, and you cannot enforce some of the communication between the systems. So if you still have a situation where your system talking to each other, you kind of doing this something like this. You are using a gateway, API gateway, and like a Kong as external the conduit proxy, something that allows things to enter your system. After that, inside your application ecosystem, you use a mesh to communicate applications. And also, you can run this like a Kafka-aware systems in a mesh. There's a filters that allow this proxy communicate and understand Kafka protocol. They can rely on also service discovery and this type of things. So your Kafka, your data awareness of the services also will be running inside the mesh. And this is kind of like this is what you will be doing if you implementing the services today. For example, for me, this type of thing would be a no-brainer back in my Kafka days. So that's what I will be doing all day long without using third-party tools. However, it is something where you don't go in for your adventure without the friends. So that's why you bring in friends like your service mesh, like a gateway, to have observable and reliable connectivity. And the third thing that's also people kind of forgetting that this is also a very valid pattern. This pattern known as event gateway. So the Kafka communication also can be kind of like this side thing to your system. And the Kong, for example, with this new announcement of the Kafka plugin, can produce to the Kafka topic and the systems who are maybe not developed even yet. So, but in future they will be interested in this data that was produced through this event gateway. They will be able to read this data from the beginning of time from event store, and we will be able to processing things. So the links there, you can find and read a little bit more about this. Also, I would like to learn a little bit more if you're interested in this type of subject. So maybe I will go and do a deep dive into this topic during our Kong Builders live streams that we do in the Kong YouTube channel. Subscribe if you're watching. Subscribe to our YouTube channel. Now, the last thing. Something that you need to remember. Gateway is for admitting. Gateway is your big, nice, fancy door to your application functionality. So it brings traffic from your clients to your application. So mesh connects your application together. So the mesh provides communication, a reliable communication, some of the traffic routings, like circuit breaking pattern inside between your microservices. And Kafka, sorry for this pun, Kafka streams. Kafka streams your data. Kafka is good for asynchronous communication for use cases where you don't know who will be consuming the data. And the same thing with this, like you don't need to expose some of your API. You will just publish this data, publish this into Kafka topic.